Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 8-3 on the tangent ratio. Here's some of the vocabulary and important information we're going to be covering today, so make sure you get this down in your notes. To begin with, just a review on the parts of right triangles. Don't forget that you have one right angle, of course, and the side across from the right angle is always known as the hypotenuse. The two sides that make up the right angle, here and here, are known as the legs of the right triangle. A brief story about opposite versus adjacent. Here's my lovely drawing of a house on the right-hand side, a lake in the middle, and a lighthouse on the left-hand side in red. So if I was to draw a person standing right here, I know my drawing is amazing, what you would want to see is that they are adjacent or right next to the house, but they are opposite all the way across the lake from the lighthouse. However, if I was to draw the person over here, now that view changes and they are adjacent or right next to the lighthouse and opposite all the way across the lake from the house. So the vantage point that you're standing at or that you're looking at does matter when you're talking about opposite versus adjacent. That's a very important concept coming up in this lesson. The tangent ratio itself is always exactly that. Just like what we just showed you, the tangent ratio is always the opposite over the adjacent. So you start from any of the angles that aren't the right angle. So this right angle is out, and the side across from the right angle, the hypotenuse, is also out. And whichever other angle you want to start with, in this case they've started here, the tangent is the opposite over the adjacent. So the opposite leg over the adjacent leg. If you wanted to go with angle P over here, you'd go opposite first and then adjacent second. But the tangent ratio is always opposite over adjacent. And an easy way to remember that is the sound TOA. T equals O over A. So in this triangle here, remember, our right angle is out and our side opposite our right angle is out. So if we were to go from angle A here, the tangent would be the opposite over the adjacent. So the tangent of angle A would equal A over B. And if we were to go from angle B over here in yellow, we go opposite over adjacent. So the tangent of angle B would equal B over A. Notice how these two have a relationship. They're actually reciprocals of each other, and tangent ratios always work like that. Real quick, you guys, when you're doing tangents, you're going to be using your calculators, and your calculators might look slightly different from this one. This one happens to be on an iPhone. I want you guys to pay special attention to what you see here. In geometry, we use degrees. So see how this one says rad? That's for radians, and that's bad. What you want to do, if this is the case, is click on this button down here that says degrees, and it will switch up here from radians to degrees. All right, last thing is the inverse of a tangent. Sometimes they will give you a triangle that looks like this, and they might want you to find the degrees of angle C. So we can use the tangent function here and go opposite over adjacent. So the tangent of angle C would equal 10 over 11. But notice this time we're actually solving for the angle, not for one of the sides. So we're going to use a function on our calculator that's the inverse of a tangent. And on a calculator, it usually looks like this. And to find that one, you would go on your calculator and you would normally have to hit the second function, and then you can find it right here, the tan -1, or the inverse of the tangent. So you would use your calculator to divide 10 by 11, and then you'd hit your tangent of -1, and it would give you a value which is the angle for C. All right, let's do some homework. What is tangent ratio of J? What about for K, or how are they related? So if we started here for J, remember it's opposite over adjacent. So for J, the tangent of J would equal the opposite 7 over the adjacent 3. And if we wanted for angle K over here, the tangent of angle K would equal the opposite 3 over the adjacent 7. 3 over 7. And again, how are they related? Well, they were the reciprocals of each other. You simply flip them over. This one wants us to solve for angle or for side W. So in order to do that, we're going to use the angle they gave us here, 54. So the tangent of angle 54 would equal the opposite W over the adjacent 10. And then we'll plug this into our calculators and solve. On my calculator, I have to hit 54 and then the button for tan. And then to solve this for W, I'd simply multiply both sides by 10. And what I'll get is that 13.76 equals W. This one, same kind of a problem here. I'm going to start here with the angle they've given me, 28. So the tangent of 28 is going to equal the opposite, in this case 1.0, over the adjacent leg, W. And now I need to use my algebra to solve for W. So I will multiply both sides by W, and then I'll divide both sides by the tangent of 28, which you can do in your calculator as well. Most calculators let you just do 1 divided by 28 tan and then hit equals, and what you'll find is that W is approximately 1.88. And here our last question is for an inverse of tangent, because they're actually asking you for the angle itself, for angle Y. So the tangent of angle Y is going to equal the opposite, in this case 100, over the adjacent, in this case 41. When you do the division, you get the tangent of Y is 2.439. Then you hit the second function, an inverse of tangent, or the tan negative 1, and you get approximately 67.71. So angle Y is approximately 67.7 degrees. Good luck, everybody. I hope you guys all do great.